Next, we will start with the type 3 system. I have considered second order type 3 system. So with this, this is the function k divided by s square 1 plus st1. The g of j omega will be k divided by minus omega square 1 plus j omega t1. The magnitude is k divided by minus omega square root of 1 plus omega square t1 square. Angle is minus 180 degree minus tan inverse omega t1. The real part is minus k divided by omega square 1 plus omega square t1 square. Imaginary part is t1 divided by omega 1 plus omega square t1. All this calculation is available in the handwritten notes. Okay, so first we'll start with the tabular column. So as omega tends to 0, we can see that as omega tends to 0, the one part gets neglected. Sorry, the omega square t1, this is neglected. Minus k by omega square is infinity. So what remains is minus infinity. So no matter what value of omega you take, the real part will always remain negative. The real part will always be negative. Okay, and coming to the imaginary part, again this is infinity. This is infinity and angle is minus 180 degree minus tan inverse 0, which is minus 180 degree. Coming to the as omega tends to infinity, this becomes real part becomes 0. Imaginary part is also 0. This is 0 and this is minus 180 degree minus tan inverse infinity is minus 180 degree minus 90 degree, which is 270 degrees. So now we will draw the polar plot for this function. Okay. Just a minute. Here we will draw the polar plot. This is the polar plot, real part and imaginary part. So initially it is both are infinity and your real part is negative. Like here, so this is real part is minus infinity and imaginary part is plus infinity. So this point will be somewhere here. Okay, so why I am taking it very near to the imaginary, real axis is because this minus infinity will be greater than this infinity. That is because here you can see this is when you put omega tends to 0. So this will be equal to, this term gets neglected and what remains is minus k by omega square. And when you put here omega tends to 0, what remains is t1 by omega. So when omega approaches 0, like any very small value, this is more this is more a larger value compared to this. Yeah, this real part will be much larger value compared to the imaginary part. So that is the reason why when both are infinity, when both real and imaginary part is infinity, we take a point nearer to real axis. We don't take it from here. It is not 45 degrees. It is somewhere nearer to real axis because this infinity is larger compared to this infinity. Okay, so now here it starts, this is your starting point. This is omega tends to 0. This point is omega tends to 0. And that is at 1. And also this point is 180 degrees to real axis. So this is so nearer to imaginary axis that, and also from angle we can say it is minus 180 degree. So this point will approximately make 180 degree to the line. So again, so if since it is making much, it is making 180 degree with the line, so it is much nearer to this real axis. It is somewhere here. Okay, so it will approximately make minus 180 degrees with the positive real axis. And the second point is when omega tends to 0, both are 0. But here it is converging at an angle minus 270 degree. So it is like, so this is the 0, but this is minus 270 degree line. So the line should converge from minus 270 degree line. So you cannot take like this, you cannot take like this, you cannot take the line like this, you cannot take the line like this, or you cannot take the line like this, because it is minus 270 degree. So it should start from here. So this is way it will merge. This is how the polar plot will converge. Okay, so this is the cupola. Now the same one, if when the same system. Now if I take type 3 with order 4, okay, so here it will be 1, 1 plus S T2. If I consider this, then this is 1 plus j omega T1 root of 1 plus omega square T2 square. This is minus tan inverse omega T2. Okay, so now your real and imaginary part will change correspondingly. So we'll see how does it changes. So your real part will become something like this: minus k 1 minus omega square t1 t2 divided by omega square 1 plus omega square t1 square 1 plus omega square t2 square. Imaginary part is t1 plus t2 divided by omega 1 plus omega square t1 square and 1 plus omega square t2 square. So here you can see the real part will remain negative when omega square t1 t2 is less than 0, and it will become positive when omega square t1 t2 is greater than 0. Similarly, imaginary part, no matter what your value is, it will always remain positive. So we'll see the tabular column. The real part will here the real part will not always remain 0. Whereas in previous case we have seen the real part was always 0, but here it is different. The real part will remain 0, the real part will always remain negative, but here the real part is negative if omega square t1 t2 is less than 1. It will be positive when omega square t1 t2 is greater than 1. Fine. And coming to the imaginary part, the imaginary part is always positive. It is always positive. So with this, the polar quadrant will remain in first and second quadrant. It will remain in first and second quadrant only. Okay, similarly here, again the same thing. The imaginary part is always positive and real part is always negative. So imaginary part is always positive. So real part negative, imaginary part is positive, which means that the quadrant is second quadrant. This is how you need to analyze it. Fine, so now we will tabulate it. So same thing, when you tabulate the plot, this becomes minus infinity, this is infinity, infinity minus 180 degree, this is 0, 0, 0, but here it is minus 360 degree. This is minus 360 degree. Okay, so minus 360 is nothing but this line. This is minus 360 degree line. So now I am plotted. It will start from this point, but now it will cross the imaginary axis and it will converge at an angle minus 360 degrees. So this is minus 360 degree line. It will converge towards the minus 360 degree line. This is the polar plot will be. Here you had seen when we had taken third order system, the angle was minus 270 degrees, so it converged only till here at exactly at this point. It didn't cross the imaginary axis at all, because we had seen both real and imaginary part would remain negative and positive respectively. Whereas in case of this, the real part is moving from negative to positive and imaginary part will always remain positive. So hence both first and second quadrant needs to be covered. And hence you start from this point, crosses this point at point A, then converges at an angle minus 360 degree. This is minus 360 degree line, so it will converge at that point. This point A is given by T1 T2 raised to 3 by 2 divided by T1 plus T2. This is your point A. So here real part is 0, only imaginary part is there. This is how type 3 system is. Right? So you can see when you increase the order, what happens to the polar plot. In the next video, we will see a shortcut method to draw the polar plot so that you don't have to do all this analysis. Okay, so we'll just see that in the next video. Thank you.